Let's now consider step 4 of our bootstrapping procedure. The goal of this step is to determine, for each time point, the value greater than 2.5% and greater than 97.5% of all values. There are many ways to do this in MATLAB. Perhaps the easiest is to sort from smallest to largest the 3,000 resampled ERP values at each time point. We may visualize the resampled ERP as a matrix, where the 3,000 rows correspond to the 3,000 resamples, and the 500 columns correspond to the 500 individual time points. Sorting the resampled ERP values at each moment in time corresponds to sorting the values in each column of this matrix. With the resampled values sorted in this way, we can then find the resampled ERP value at appropriate indices. In this case, we need to find the value at index 0.025 times 3,000, where remember 3,000 is the number of resamples we perform. That product is equal to 75. And we also need to find the resampled ERP value at index 0.975 times 3,000, which is equal to 2,925. Consider what these indices represent. These indices correspond to the resampled ERP value greater than 2.5% of all values and greater than 97.5% of all values at each moment in time. Therefore, these indices specify the lower and upper confidence intervals at each moment in time. We can compute both confidence intervals in MATLAB, and finally, plot the ERP for condition A with confidence intervals computed using the bootstrapping procedure. We can use these results to identify, for example, intervals in which the ERP differs significantly from 0. To do so, we find periods in which the confidence intervals do not include 0. We find that our results plotted here are very similar to our previous analysis of the ERP with confidence intervals, where in that previous analysis, we computed these confidence intervals using the normal distribution and the central limit theorem. We've now considered two ways to establish a confidence interval for the ERP. The advantage of the bootstrapping procedure over the other approach we considered is that this procedure requires few assumptions about the distribution of our statistic of interest, in this case the mean. And we can use the observed data to probe the distribution of this statistic, here by resampling. The disadvantage of this bootstrapping procedure is that it's computationally intensive. Here we considered 3,000 resamplings, but we could easily consider more.